Hi everybody, this video is on transforming formulas and equivalent formulas. One thing to remember before you go into this is that all the arithmetic you've ever learned still applies. So if you lose confidence, you always can substitute in simple values and double check what's going on. And as always, remember what you learned in elementary school, because this is exactly it. It's just the patterns that you learned in elementary school. So for our quick first example here, we have a little rectangle which measures 3 by 2, and its area, in other words the number of squares that it occupies, the space, is 2 times 3, 6. So there are 6 individual squares here together. The formula for that, as you hopefully recall, is that the area is going to equal the length, 3, times 2, the width, and that's going to give us an area of 6. In this case, 6 square units, since we don't have any units specified. So this would be 3 units long, 2 units wide, and the area is 6 square units. So when you write an equivalent formula, the terms that they'll use is that this equation right here is solved for A in terms of L and W. So A is what's solved for because it's alone, and the terms that are used to describe it are L and W. So at various times you're going to want formulas solved for different things, and this is a fairly nice simple formula because it's related to the fact family, and most everyone will remember that if you had the product of 6, the factors there are 3 and 2, and 6 divided by 2 is 3, and 6 divided by 3 is 2, and of course 2 times 3 is 6. So in this situation, these are all going to be interrelated. So if you had to solve, however, for the length, let's say we're going to start down here and we have the exact same formula, area equals length times width. You want to solve for length. You want the length to be alone. You want it by itself. So this is multiplication by W. You can divide by W to both sides to be fair and consistent, and that goes away. And the length, then, you are now solved for the length. I'm going to flip-flop this, starting with L. L is equal to A divided by W. Now that may seem a little scary at first because you don't know what A is, you don't know what W is, you don't know what L is, but if you check with the original thing, the length, that would be 3, is true that 3 is equal to the area 6 divided by the width, W, 2. Yep, that checks. Now, over time, you shouldn't have to really check this, and you should be totally confident. One thing you might want to notice is that if you're dividing by W, W cannot be 0. Okay, so in this next one, if you had to solve this for W itself, you want to get rid of the multiplication by L. So you can divide by L, and sure enough that L's will cancel. W is equal to A over L. This is now solved for W in terms of A and L. If you want to use reciprocals, say again, if we were solving here for W, you could multiply by the reciprocal of L, 1 over L, and you would still get the same answer. So you get 1 times A is A, and then 1 times L is L, so it's A over L is equal to just plain old W. The L's will cancel. Same thing. Okay, so here's another recent formula from your science past, that distance, how far you travel, is related to the rate, which of course is given in some sort of unit of distance per time. It becomes a new unit, a rate unit. Distance is equal to rate times time. So an example would be if you're traveling 40 miles per hour times 3 hours, these things will cancel, and your answer comes out to 40 times 3, 120 miles. Okay, that should make sense. This is a distance. This is a rate in miles per hour times hours. Your answer comes out in miles. Okay, well, what will happen if you need to solve this, not for distance, but if you need to solve it for rate? What will happen if you solve it just for time? There's multiplication here. Go ahead and solve this. So I'll transform the formula, distance equals rate times time, so that it is solved for rate. Then do it again and solve it for time. Go ahead, pause the recording. Okay, so hopefully you got something that looks like this. In the first case we have distance equals rate times time divided by rate. And so distance divided by rate equals time. That's sort of like saying the 120 miles divided by 40 miles per hour will give you a time of 3 hours. The second one, distance equals rate times time, and you are solving for r, the rate. So you're going to divide both sides by time. So distance divided by time is equal to the rate. Now that should make sense because that'd be like 120 divided by 3 hours is going to come out to 40 miles per hour. Okay, so in this case you're solved for r in terms of d and t. In this case here you're solved for t in terms of d and r, and up above of course you were solved for d, the distance, in terms of rate and time. Okay, so here's another familiar formula for you. This is about the perimeter of a rectangle. You have two widths that are the same, you have two lengths that are the same. It could be written this way: take the length and the width, add them together and double them. Or it could be written this way, with the distributive property cleared out: the perimeter is equal to double the length plus double the width. So right now, if you could please solve these in terms of W and in terms of L. Remember, you can, in this case, you can use either one. If you use this case, you are going to need to use SADMAP, use undo addition first, although since this is a 2 in both, you probably could get away with dividing by 2 first. In this case, you could either clear out the parentheses to wind up like you are in this problem, or you could divide by 2 in the beginning. Okay, good luck. Okay, so hopefully you were able to work through that. On the right hand, or on the left hand side here first, okay, I simply saw in this case to solve for W. So I took away 2L from both sides. I did P minus 2L. I got this answer right here. That was equal to 2W. Once I got the 2L out of there, and that all canceled out. And 2W is equal to P minus 2L. Then you divide by 2. So essentially W is going to equal to P minus 2L divided by 2. You also could have 1/2 P minus L. That would be the exact same thing. In this case, I chose to divide by 2 first to cancel here. So I have P divided by 2 as one element. And now when I was left with L plus W, I take away the W. Okay, and you're just left with L now, as that's P divided by 2 minus L, which would have been the exact same thing if you had P minus 2W all over 2. That's also equivalent. So any of those solutions would be fine. Okay, so for your homework, here are 4 questions which you can transform for the indicated variable. In the first case, you're going to solve for pi. Second case, you're going to solve for r. Third case, you're going to solve for c. And in the fourth case, you're going to solve for m. So run through those 4, and then we'll have a couple more for you after that. Run through those 4 first. Okay, so for the last one, this is about trapezoid area. So trapezoids are figures that have 2 bases. They are parallel, but different in size. And then they have a height, which is not equal to these sides, which may or may not be right angles. In this case here, they are definitely not right angles. Formula is base 1 plus base 2 times 1/2. In other words, the average of these 2 bases times the height. That gives you the area. So this is solved in terms of the area, or solved for the area in terms of the 2 bases and the height. So go ahead and solve that for B. And when you get that done, using another trapezoid, if the area of this is in fact 30 centimeters, use your answer from above to solve to find out what B1 is. So you actually could either plug it in the original, or you can use the equivalent formula that you created when you solved for B in order to get the value of B1, I should say. Okay, good luck. Show all your work, please. Thank you.